For this problem, you had given n parentheses. Your target is to generate all combinations of well-formed parentheses. Suppose you have a n equal to 3, and then you have 3 open parentheses and 3 closed parentheses. If you generate different combinations of the parentheses, you can get samples like this. You can have samples like this. You can have samples like this. And multiple possibilities. So how will you generate all this? This is a kind of a recursion problem. This is a recursion problem. So how will you form that recursion is the problem question. So you can keep track of the number of open parentheses and closed parentheses you had used. We will bring the n down to 2. That will be faster for explanation. N down to 2 will be like, this will be 1 and this will be 1. Are there anything more? No, I guess these are the only 2 possibilities. Okay, we will go with n equal to 2. So when you will keep track of number of open parentheses and closed parentheses you had used. Initially you had used 0 open, 0 closed. When 0 open and 0 closed, you can use 1 open. 1 open, 0 closed. You have maximum 2. So you can further, this is the only option you have. You have to use 1 open because you cannot start with the closed. So 1 open, 0 closed. Then what you can do, then you have 2 options. You can use a closed. So it will become 1 open, 1 closed, or you can open second one. So there will be 2 open, 0 closed. This is the maximum you can open. So now you have to close. So it will be like 2, 1. Then again you close 2. Here, right now you have 1 open, 1 closed. They are tallied. So you cannot close further without opening. So you have only one option. Open it, then close it. This is the stack you will be forming. So when you are here, you will have 1 open parenthesis. When you are here, you will be having 2 open parentheses. At here, you will be having 1 closed parenthesis appended. Finally, you will see the result of this path. If you go to the second path, it will be like you will close it first here. Then you have open and closed. Then you again open, close, open, then close. This will be the second answer. These are the 2 paths you will be exploring for n equal to 2. If you pick n equal to 3, you will get even bigger tree and you can explore it. So the only variables you have to keep with you is open parenthesis and closed parenthesis. You can open, allow to open if open less than n. Allow to close if closed less than open. These are the 2 conditions, 1, 2. So by using these 2 conditions, you can solve this. Let's program it. That was solution. Okay. Let's program it. You need a generator. You will be recording your answer, and you want pass integer n. Then open parenthesis, close parenthesis, count of open parenthesis. Create the generator. Generator returns thing. Our answer container passes a reference. I will return that one. Answer. So create generator. So you need the vector to be passed as a reference. Integer n, integer open, integer closed. And obviously you require your answer a temp variable. Maybe we can fill it as empty string. Pass it here. The first condition, open less than n. Then generator, answer, and open plus closed, temp plus you are opening it, so open. Then what you can do is, this is the first condition. You had added on open braces, on open parenthesis. Now if closed less than open. If closed less than open, then you can add a close parenthesis and append that with your string. That's all. And you have to stop, you have to record your result. If the temp.size equal to 2n, then you can stop, then you can record the result and return. That's all. That's all about solving this problem. Let's see the result. It gave you too many solutions, too many parenthesis combinations. It will reduce the test case into something 2. If it is 2, then you have a limited number of solutions. Okay, for 2, as we discussed, we had received 2 combinations and the solution is correct.